everyone, and welcome to Physics Rocks. My name is Ms. Hu, and I am a physics teacher. So, what we're going to be doing in this video is we're going to be observing Bernoulli's principle in application using this apparatus. So, what exactly is this apparatus? So, this apparatus is made up of two tubes. We have over here a uniform tube, and on the other side is a Venturi tube. First of all, let's take a closer look at the apparatus. So, on this side, we have the uniform tube. It's called the uniform tube because, as you can see, along the horizontal tube here, the diameter is uniform. Along the horizontal tube, we have three vertical tubes. Now, on the other side, we have the Venturi tube. For the Venturi tube, we also have three vertical tubes along the horizontal tube, but if you take a closer look at the horizontal tube, you'll find that the diameter is not uniform. In the middle, you'll find that the diameter is a lot smaller. So let's understand a little bit better first about the apparatus before we actually observe the water flowing through the tubes. So the purpose of these vertical tubes for both the uniform tube as well as the Venturi tube is to show the value of the pressure of the water that's flowing at that point, which means that this tube will show the pressure of water when it's flowing through this point, this tube at this point, and this tube at this point. We're going to connect the water in such a way that it will flow in through the tube on this side on the left and out through the right. We want to observe how the pressure changes as the water is flowing through the horizontal tube. For the uniform tube, because the diameter is same throughout the entire tube, this means that the speed of water as it flows through this tube remains the same. For the Venturi tube, same concept with the three vertical tubes. But because the horizontal tube section in the middle here has a smaller diameter compared to the left and right side, where the diameter is smaller, when water flows through this point in the tube, the speed will be much faster. And we're going to observe how the pressure changes when the speed increases in this middle point. If you're trying to remember or try to understand how come when water flows through a tube that has a smaller diameter and the speed increases, it's because you got to remember that when water flows through the tubes, it has to maintain the same flow rate. Because the diameter is smaller, that means there's less space for the water to flow through. More water needs to flow per second in order to maintain the same flow rate. That means it's not the speed. When the water flows through the larger tube, let's say there's a particular flow rate of, for example, say 1 cm cube per second. When it gets to the smaller tube, it needs to maintain that 1 cm cube per second. But because the diameter is so much smaller, there's less space for the water to flow through, the water has to move a lot faster in order to keep the same flow rate. If it does not maintain the same flow rate, what's going to happen is it's going to backlog or traffic jam, if you will. And there's no such thing as traffic jam when it comes to water flow, because water is continuously flowing. So in order to maintain the same flow rate, that's why in the smaller section, the speed of water has to be much higher. So let's observe what happens to the pressure of the water as it flows through both tubes. So let's start first with the uniform tube. Now, as we remember, for the uniform tube, because the diameter of the tube is uniform throughout, the speed of water will be the same throughout. We've already got the system hooked up to the water supply, so water is going to flow from left to right. Now, let's see what happens to the water as we switch on the source. What we want to do is we want to observe the water levels in these three vertical tubes, because these will show how the pressure of water is at these respective points along the tube. Now, I will have to admit that this setup is not exactly ideal because we're not getting a steady flow of water, possibly because of the water source. So let's look at the results in spite of this issue. So it's very intermittent, but as you can see, if we take a closer look, you'll find that the water levels are decreasing as it flows from left to right. So the water level is the highest on this tube, followed by this tube and this tube. It's very intermittent, but you should be able to see the water levels. What this tells us is that this point has the highest pressure, followed by this point and this point. We already know that water is flowing from left to right, and this means that the water pressure is decreasing as it flows from the source outwards, or in this case from left to right. So now let's take a look at what happens if we hook up the whole system to the Venturi tube. So now we have the water source connected to the Venturi tube this time. So the Venturi tube is the one where the tube is not uniform in diameter. The one in the middle has a smaller diameter compared to the sides. So let's observe what happens to the water pressure as water flows through this tube this time. So we're going to switch on the water source. And you can see how the water is coming out over here with the highest pressure. So let's take a closer look. Again, this setup is not exactly ideal because if I switch on the water source, you'll find that the pressure on the first tube is the highest. And by right, this should have the lowest pressure, and this water pressure should be somewhere in the middle, but that's not what's happening. You'll find that the pressure here is quite low, but for some reason, the water flow is not able to flow properly here. So you can see that there's actually a little bit of airspace over here, which is why the water pressure here is not getting up to the middle as it should be. So this apparatus doesn't exactly show us what we should be seeing in terms of Bernoulli's principle, and possibly again because of the problems with our flow rate from our water source. So again, you can see that water pressure is very high in the first tube. This is much lower, but the third tube is not able to show us the correct water pressure. So my apologies, I wish I could make this a better video with better observations of what should be, but due to the limitations that we have in terms of the apparatus that we have as well as the water source, I can't show you exactly how the results should be with the uniform tube as well as the Venturi tube. But anyway, not exactly the best show in terms of the practical observation, but now you can say that, hey, at least I've seen a video of the actual apparatus, and even if you see this in the real school lab, that's what you're going to see. So we're going to learn this more in proper theory as to how the water flow should be exerting the pressure in both the uniform tube as well as the Venturi tube. But in the meantime, I hope that you found this video at least a little bit more helpful in observing what you should be seeing in the school lab. Thank you for watching. Don't forget to click like and remember to subscribe to my YouTube channel, Physics Rocks.